Abstract classes are a piece of functionality that I mentioned really for the first time in the video entitled Pure Virtual Functions. Now, if you watched that video already or you're familiar with Pure Virtual Functions, then you're good to go here. If not, go back and watch that video and then come back to me here, okay? So, start off with the bottom line. What is an abstract class? An abstract class is a class that contains at least one pure virtual function. Now, what exactly does abstract mean? And so you're probably already thinking, wait a minute, concrete, abstract. Concrete means something I can see, touch, feel, that sort of thing. Abstract means something, a little less solid. And in a programming sense, we're talking about a class that I cannot use to define objects. All right. Now, what that really turns into is a base class that simply must be inherited from to be able to use any of the functionality that might be in it. All right. So an abstract class is one that you must derive a class from it to be able to use it. Okay. So any classes, before you can use an abstract class, let me say it this way, you will have to build another class, inherit from your abstract class. Okay. Now, again, let me warn you, C# and VB.NET people, and maybe even some other languages, be very careful with C++. Some of these terms that you see, and you'll assume, oh, well, I know what an abstract class is and how you can use it. Be very careful. Go dig into the C++ world, because in C++, an abstract class can contain data members, meaning variables, and function members, meaning functions that do have code in them, along with pure virtual functions, and it's still going to be noticed as an abstract class, and you will see more of this in the example a little bit later on in a separate video. Now, when you inherit from an abstract class, all your pure virtual functions must be defined. Now, if you don't, the derived class that you're working from is going to be reported to you by the compiler as an abstract class itself. So the bottom line is, once I mark a function as a pure virtual function, then if it gets inherited into another class and I don't write code for it and I don't satisfy that pure virtual function aspect, then whatever class is inheriting from the base is going to be considered abstract as well, because it has an incomplete pure virtual function. I'm using the word incomplete kind of loosely there, okay? Now, the constant keyword that you use in defining a pure virtual function is also a condition of overloading. So if you leave it off, then the compiler is not going to consider that this is satisfying the pure virtual function definition. Okay, so just make sure of that. You're going to have to match that signature pretty much exactly. Now, you haven't seen an example of what a pure virtual function looks like or anything, because I want to present the two ideas each in their own video and then come back and show you a pure virtual function example. So that's what we're going to do in a separate video, and you'll see a pure virtual function example out there in your work files folder, and then you'll be able to see exactly what's going on by going through that code. Now, the best way to understand this is to see it in an actual code example. So join me in the pure virtual function example video and we'll take a look at one. Now let's take a look at an example of a pure virtual function. Now this is in a project entitled, you'll notice right up here, Pure Virtual Function, and it's just like all the other examples set up in the course the same way, so I won't take you through that whole thing again. Now notice we have our main function here, and then I've already got the beginnings of my class cat. Now this is going to be my base class. Now notice I've created some data members here, mAge and mWeight, and those are both integer data types. And what I want to do now is I want to make sure that any class that inherits from cat uses or has a inoculate method, okay, or an inoculate function. But I don't really know what to code here. I don't want to put any code here, but I want to force every other class that derives from this or inherits from this cat class, I want to force them to have to put an inoculate, and I want them to call it inoculate, and I want it called a certain way. And so what I can do here is, first of all, I'm going to let me just do this, and I'm going to do a real simple example. I'm going to create a inoculate function that's void, doesn't return anything. Okay, and so there it is. Okay, now to make it virtual, obviously I have to put virtual in front of it. Okay, and then at the end, to mark it as a pure virtual function, or to mark it as a virtual function, I'm going to put const equal 0. Now I don't want to go into this right now, but this is basically saying that this function can't be used to change data members and so forth of the base class. There's a little bit going on there. Research that yourself. Don't want to go that deep right now. Okay, I just want you to see virtual functions now. So pure virtual function, that is the signature for it. Notice the constant equals 0 on the end and the virtual right here. Now that just made some serious changes to this class. This just became an abstract class. Okay, now I can put other functions in here that have functionality and code with them if I would like, but I'm going to keep it simple for right now. And so then I'm going to come down here in the main class, and I'm going to try to create an instance of that class. Okay, so if I call cat C1, notice that if I do C1 period, it'll show them to me, but notice if I mouse over this, it's saying, wait a minute, you can't use cat. It's an abstract class, so an object of an abstract class is not allowed. Okay, and so what I'm going to have to do, let's remove this. I'm going to have to create another class and inherit from that one. Okay, so let's come down here and let's do our class Persian again, and we'll do public cat. And notice I am going to copy and paste something in here so that you don't have to watch me hack at it here. Notice I've put a virtual void inoculate constant in here, and then I've just got my standard out. Now notice if I come down here now and try to create Persian as C1, no red line, there's everything, and I can call inoculate. Right? Now notice what it's saying here. The function inoculate is inaccessible. Okay, and I've got to come out here and mark it as public, and now everybody's happy. Okay, but now let me show you what's going to happen if I don't define this right. The easiest way to show you how particular this is, I'm just going to delete a letter out of inoculate, not a word, but a letter, and notice immediately this says notice the error message this time. Object of abstract class, and I'm reading in this little box down here, object of abstract class type Persian. It now sees Persian, it now sees this class as abstract. Why? Because I haven't correctly implemented this pure virtual function. So it sees it now as a pure virtual function down here. It hasn't been implemented, and I would have to inherit from here or correct this one to make that one behave. See it go away as soon as I made that exactly the same. Now again, the constant keyword is also a part of that. Notice it popped right back, so I've got to make sure that I have the constant keyword on there. So that is a pure virtual function. Just by putting one of these with this signature in a class makes it abstract, and it makes every class that inherits from that base class abstract until you correctly implement that particular pure virtual function. Okay, I hope this helps you understand pure virtual functions. Now this gives you, I hope a little light has come on in your designer developer brain. This gives you a lot of power in ensuring that this base class, number one, when it's inherited, you're always going to end up with an inoculate method with this signature. All right, this one is void and it doesn't have any parameters. So I could now create one that has, different parameters and so forth, and it's going to have to be implemented properly in any derived class, or they're going to have a problem. Okay, so this is just a way of ensuring that things happen. Now that's a real simple overlook at pure virtual functions and how we use those in abstract classes.